we have another lesson here on factoring. This is some more advanced factoring, which sounds so fun. We are actually going to be talking about factoring when you have a coefficient on your x squared term. So that's why I'm calling this advanced factoring. It takes a little bit more work and a little bit more maneuvering, if you will, to find the right factors that work. So our goal with doing this is to be able to, again, solve quadratic functions. Notice when a, that first term, is not 1. So when we have a 2x squared or a 5x squared or something in front of the x squared. We also want to know when this method is appropriate and when we should be factoring. So looking at this, you can see that my first number, my a, my coefficient of the x squared is 5. That's about as high as you want to go. If your number is higher than 5, factoring is probably not a great option, okay? There are exceptions to that, but for the most part, if you're going to be factoring, you want your a, your coefficient of your x squared term, to be 5 or less, okay? Once it gets bigger, it's a little hard to deal with. Now, you can work with that because your first step that you want to do is see if there's anything you can factor out. I look at this and I see, oh, all those numbers are divisible by 5. So maybe I should divide out a 5 from everything. And look, when I do, lo and behold, I have a nice little quadratic where a is 1. I can factor this pretty easy because I know that factors of 12 that make 1 are 3 and 4. And I know that if I take 3 minus 4, I get a negative 1. Therefore, my solutions must be x equals negative 3 and positive 4. So if you can find a common factor to take out, sometimes that makes your life super easy because now all of a sudden it becomes very easy to factor, okay? So you always want to divide out anything that is in common. Now looking at this one, I can very clearly see I can take a 2 out of all of these. I'm going to do so, and I get x squared minus 10x plus 9 equals 0. This I can factor pretty easily. I'm going to break apart the x squared, into x and x. Then I want to think about what factors of 9 are going to add to give me 10. Well, clearly 9 and 1 are going to add to give me 10. How do I get negative 10 with that? I use negative 9 and negative 1. Therefore, my solutions are the opposite, which are going to be positive 9 and positive 1. So if I graphed this quadratic, I would have my x-intercepts at 1 and 9. Okay, so first step is always to look for a common factor. I would say a fair amount of time you have a factor that can be taken out, and then you can factor what's left, and it makes life a lot easier for you. Now, step 2, what if we don't have a common factor? There's nothing that goes into 3 and 8 and 5. We want to then factor the first term and the last term. Find the factors that when multiplied add together to be the middle term. So instead of just breaking my y squared apart into y and y, I actually need to break that 3y squared apart into its factors, okay? So let's start with here. What are the factors of 3? 1 and 3. What are the factors of 5? 1 and 5. So this one's kind of nice. I don't have many factors I'm working with. I just need to figure out how to position them. So I'm going to start with my y squared. I know that the first parenthesis is going to be 1y, the second parenthesis is going to be 3y. I don't care if you interchange those, it doesn't really matter. I just wrote them in the order that I wrote them, okay? Now, I want to position the 1 and the 5 in these parentheses to somehow make 8. So I'm just going to do 1 and 5. How do I know if they make 8? Well, I multiply these two, which is 3y. I multiply these two, which is 5y. Can I add those to make 8? I certainly can. 3 plus 5 is equal to 8. So I'm just going to add in my plus signs because I'm adding, and now I've got that factored, okay? If I had added them and not gotten 8, then I would have switched the 5 and the 1 to see if it would work there, okay? We'll try that in a couple others. Now, this isn't done. Remember, your goal is to still solve for y. So you have to solve for y in each parenthesis. So remember that we take the parenthesis, we set it equal to 0, and then we solve. Here I'm going to subtract 1. Now in the second one, I'm going to subtract 5 and divide by 3. So my solutions here are negative 1 and negative 5/3. When you are factoring, when A is not 1, you will get fraction answers. That's okay. That's what it should be, okay? Notice, I'm still taking the opposite. My parenthesis was plus, my answer is negative. I'm just taking the second number divided by the first. So it's kind of a little shortcut for you, if you can remember that. Take the opposite of the second number divided by the first. Let's try this one here, okay? So I'm going to start again with factors of 5, which are 1 and 5, and 3, which are 1 and 3. And I'm going to try to break this apart. Now, pause a second. Did I look for a common factor? I didn't say it, but yes, I did. There's nothing that goes into 5, 16, and 3. So I know I can't take anything out. I need to factor my first and third terms to try to get that middle term. So I'm just going to put them in my parentheses. I'm going to put 1x here, and I'm going to put 5x here, and I'm going to put 1 here, and I'm going to put 3 here. Let's see if we can add to make 16. So 1 times 5 is 5. 1 times 3 is 3. 5 plus 3 is not 16. So what I know is that I have gotten these in the wrong position. So what I'm going to do is I'm going to erase my numbers, and I'm just going to flip-flop them. So before I had 1 and 3, now I'm going to try 3 and 1. And hopefully this time it works. So 3 times 5 is 15. 1 times 1 is 1. And 15 plus 1 equals 16. So I'm good to go. I got the number. Now I need to try to get the minus sign. Clearly negative 15 and negative 1 is what gets me negative 16. So you may have to sort of move factors around or even try different sets of factors to see if you can make that middle number. It's okay. I guess I would call this a guess and check method. Guess which factors you think it might be, and you can get smart about this, and then try them out to see if they actually work, okay? Now remember, I'm not done. I still have to solve. So x equals, in this first one, the opposite of negative 3 is positive 3, divided by 1 is 3. The opposite of negative 1 is positive 1, divided by 5 is 1/5. Those are my two solutions. Okay, remember that what I'm doing is I'm taking this and I'm setting it equal to 0 and I'm solving. I'm taking 5x minus 1 equal to 0 and I'm solving. I'm just using a little shortcut to try to make it less time consuming for myself. Okay, let's try another one here. This time I have got a 5 and a 6 that I'm working with. So this is going to be a little more tricky because while 5 only has 2 factors, 6 has a couple pairs. 6 is 2 and 3 and 6 and 1. So here's my helpful hint, if you will. Start with the one that only has one pair. I know this is going to be 1x and 5x, simply because I don't have any other options. Then guess with the others what might work, okay? And remember that we are adding our terms to try to get 13. So I'm going to start with 2 and 3 because I wrote it first. And I'm going to go 2 and 3. Now, do I have 13? 2 times 5 is 10. 1 times 3 is 3. And luckily enough, I got 13 on my very first try. How fun is that? I didn't have to switch anything because 10 plus 3 is 13. I'm good to go. I need to make them both negative because that's how I get the negative 13 of my middle term. Then I'm going to solve. My first parenthesis, I'm going to say positive 2 divided by 1 is 2. My second parenthesis, positive 3 divided by 5 is 3/5. And those are my two solutions. Okay, so again, I'm factoring the first and the third term, trying to make it equal the second one. Now this one, I'm going to look first because 4 seems kind of big. Can I divide it out of everything? Well, 4 goes into 28, but it does not go into 49. So I cannot divide it out because it doesn't go into all 3 things, which tells me that I'm going to have to factor, okay? Now, 4 is 1 and 4 or 2 and 2. 49 is 1 and 49 or 7 and 7. I'm going to go out on a limb here and say that 1 and 49 is probably not the right choice. So I'm going to go with 7 and 7 and see if I can work the other stuff to make 28, okay? Now, looking at these first pairs here, either 2 and 2 or 1 and 4, which one do I choose? Well, here's the thing. If I choose 2 and 2, I only have to do it once. Because even if I switch them, it's still 2 and 2. So if it works, great. If it doesn't, I move on to 1 and 4. So again, yes, it's guess and check. I'm air quoting, but you can be smart about how you guess, okay? You can make an educated guess so you don't have to do as much work or as many attempts to try to find the right numbers. So really try to be smart about how you're choosing these, okay? So I'm going to multiply 7 by 2 and get 14. I'm going to multiply 2 by 7 and get 14. And I know that 14 plus 14 is 28. I need positive. This is one of those double roots again. So I'm going to take the opposite of 7 divided by 2 is negative 7 halves. Again, remember you can write it once. You can write it twice to designate that it's a double root. Whatever you feel like you need to do or whatever your teacher tells you you need to do is important here. Okay? So that one was a little more complicated, but because we guessed in a smart way, it actually wasn't that hard. So again, try to be thoughtful about how you choose your factors to use so that you don't have to try 7 different combinations. If you think about, like, is it odd? Is it even? Which pair makes the most sense with the middle number that I'm trying to get, and kind of work from there. You should be able to do this a little bit quicker and make a little more sense for you. As always, this has been Conalonzo Inc. bringing you information about math. We have been solving quadratics. Hopefully you are really starting to get the hang of factoring. If not, let us know. We're more than happy to help. Hope you're doing well, staying healthy. Take care.